live tracker. All of this dashboard is coming from the Sense API, and what we are doing is using the camera which is facing the entrance to identify people coming in and out, drawing a virtual gate so we can know when the rectangle that represents the person identified by the camera transition over this virtual gate, and we can count in and out from there. And also we are using instead the fisheye camera to draw the heat map, the live heat map. So the more red, the more people are in that area. And also the other map, which is the live tracking. So we can see live rectangles, which are the people detected by the camera right now moving around the store. From this data, we can have the area live, which is the live count of people underneath the camera, or the dwell time, which is the mean time spent by a person in the field of view of the camera. And we also get this data, we store this data for historical analysis, like area history or people detection or camera in and out. All of this data is stored by the platform, so we can have different kind of analytics or insight of data collected from the cameras. One more thing that we do with camera is the phase analysis. So whenever we detect an in from the camera, in this case we use an MV12 camera, which is best suited for this kind of task. We take a snapshot and send the snapshot to Amazon AWS Recognition, which will do the phase analysis and returns back the information like the age distribution or the gender or the emotions, and it gives also other information on the derived from the phase analysis, which can be useful for people profiling without using any kind of page or app or something else. In the same dashboard, we also put some analytics from the Wi-Fi. So on the right side, we have some information from location API from Meraki, from access point, where here we are calculating the busiest day or busiest hour or mean time of Wi-Fi session. And we also integrated system manager, because we are tracking in this example 5 people device, so we can know when each one enters and leaves the office. This is an office in Rome. This is coming from an office in Rome, where we are using the system to, instead of the classical badge, for to know when people enter and leave the office. So we have the timetable of the people in the office, only using Wi-Fi their devices, system manager, and Meraki Wi-Fi. All of this is coming from the View platform, which is the engine which is under the operation of the platform. And this is, for example, the way that we draw the process of the data, the acquisition of data from the different Meraki API. And this is the diagram of what we do for the dashboard, the demo dashboard for the MV cameras. This is just a sample of what we can do with the platform behind. So we get real data from the MQTT broker used by the Sense API. We process this data, and we use a complex event processing engine to detect in and out, people count, dwell time, or the heat map, or the tracking live of people, and so on. And this is done all using this platform. One more example of what can be done using the VAPP platform, for example, is this demo enterprise dashboard, where we have a drill down style dashboard set, where we start from a main dashboard. And this example, we have 5 stores located in the United States, and we are proposing here an aggregated data coming from Meraki. And in this example, we have data from the cameras, so we have the most visited store taken from the cameras in the store, but also the traffic history taken from the traffic API from Meraki Dashboard, and also the top 10 application used inside each store, and this is the aggregated data from there, which is something that lacks in Meraki Dashboard. So usually in the dashboard we have information and the analytics on a single network. This way we can aggregate multiple networks and also multiple organizations in one dashboard and have a drill down analysis, so we can look at a single store, and here we have the same data of the demo from the cameras, but also information about the store top 10 application or the popular times in the store and passers-by and so on. So this is just another example of what can be done using the platform, which is totally customizable. One other kind of application that we are doing with the same using the same platform is, for example, the network side, the network tools that we have developed for the Meraki with Meraki integration. So, for example, we have developed a tool for the historical bandwidth usage where we have 90 days of historical data, so we can see what happens in the past with the traffic in the analyzing network. Or, for example, for firewall backup automation, where we can take a backup of all the firewall rules in Meraki Dashboard with just a single click. And we can also see the rules which are backuped here. This is just a lab firewall with no rules inside, but we can also restore them, and we can also automate this kind of backup using webhooks. So we can, for example, connect this backup on every configuration changes, so we can do automatic backup whenever someone makes a change in the configuration. The same can be done for the Wi-Fi backup or the VPN backup or the switch backup and so on. And we can also manage to have all these backups taken together, so we can have a full set of backup for a single network or for a single organization in all. We have developed also an application which integrates with WebEx, so we can deliver alerts using WebEx channel. So we can configure, for example, in Meraki Dashboard a provided email address, and using this address, all the alerts sent from the dashboard will be sent also to the WebEx bot. And we can also use here the WebEx webhooks to deliver the alerts. We have also a Telegram bot, which is similar in functionalities. And we have also developed some application for the Wi-Fi analysis. We start from, for example, from the Wi-Fi coverage survey, where here we are using the location API, so collecting data from the SIM device by the access point in the deployment. We are building this map where we have the RSSI, which is the received signal of each device seen by the deployment, and we can add this on a map and see how the deployment is working, if there are black holes or areas which are not well covered by the Wi-Fi signal. All of this is done automatically using each device seen like a sensor, like a probe, and there is no need to go around with a laptop and do Wi-Fi analysis. And also is automatically updated, is continuously updated. So whenever there is a device, this data is collected, analyzed, and represented on the map. And so we can have a survey, an automatically updated survey of the site. Something similar we have done with the putting together the location API and the health API from the dashboard, and we have the latency map, where we have the map of the different access point in the deployment with latency information together, and also connected devices how are performing in the network. Right now this is a small network, there should be another one. Okay, for example, this is deployment in Casablanca, where we have several access points, some performing very bad, and the hexagon are the devices and with their latency, so we can see if there is, for example, here we have one device with a high latency, but is connected to an access point which has a good latency, and probably this is a client problem and not a Wi-Fi problem. So we can manage and see how the Wi-Fi deployment is performing, also at the network layer and not only at radio layer. Also, using the location API, we build up an application which is called the concentration map. So we can put a floor plan here, for example, and draw some rectangle, some area, and monitor how many people are there in the area, in live or in history. So we can know, for example, this is a good way for a good tool for the retail store. So we, for example, can have the store map and draw different areas and count devices in different areas of the store. But this is all, of course, based on Wi-Fi information. So it involves also macro-randomization and not well seen, not real count of devices there. All of these integration are done, as I said before, with the View platform. And here the key point of the platform is that the platform has a lot of different components for doing integration, and also for doing rules where we can automate some kind of the integration done for Meraki. For example, we have deployed a system where we control a digital monitor whenever there are people seen by a camera. So I have an event of more than one people in an area. I can drive the monitor to show some customized content for that area, for example. And all of this is done using this kind of tool, where we can integrate different kind of solution. And of course, Meraki is fully integrated with their API. And okay, so this is what we are building right now with the Meraki integration and the VAPP product, which is the customization of the platform for the Meraki integration.
Real-time flow.
Okay, yes. We have another. Okay. This is the dashboard that we've built for Alstom, which talked briefly Antonio before. And here we are analyzing the people flow in the parking in Florence. And this is the overview. So these are all the cameras that we have deployed in the parking. And this is the number of people flowing in all the parking, all day by day. And we can have a view on a single camera, so we can know how many people are flowing on a single area of the parking. This is the tram area, for example, and this is, for example, a live person which is going downstairs, I suppose. And here we have the flow, the number of people flowing in the camera. And for the network, we have this one.
As you can see, we don't get access to the live stream video because this is not accessible by API. So we just get the data from the API, and we collect a snapshot from the camera every 30 seconds.
No, every 10 minutes.
10 minutes.
But it's just to have an idea of what the camera is looking at, and we only draw the live tracking of people there, so the rectangles which are the people identified by the camera. So there are no privacy issues in this solution. This is another tool that we have built using the Meraki API, but using a remote probe. Here we are collecting the net flow from the Meraki devices and sending this net flow to a remote probe which is connected to the platform, so we can have a live view of the traffic collected by this probe here on the left. And on the right we have the historical data from the top traffic, so the top source and destination, which made the most traffic in the last day, for example, or the top sources or the top destination. And we can also choose a period over which made the analysis and do the analysis of the traffic using NetFlow.